In this class, we will use MongoDB as an example JSON store. Mongo was first started in 2009 and has been one of the most widely used JSON document store since then. Mongo was first designed as part of the NoSQL movement to support web applications. It implements base, as we talked about earlier. As part of the trade-offs, Mongo provided limited functionalities. For instance, it doesn't support joins. And also, no transactional support for writing to multiple documents concurrently. And initially, it doesn't even check that each JSON document it stores is well formatted. Despite these limitations, Mongo has evolved into a mature system that can teach us a few lessons in NoSQL database design. In this class, we'll cover its data model and query language, and then discuss a bit about its internals. MongoDB's data model is JSON, as we talked about earlier. The only thing that is new here is the ability to store JSON documents in binary form as opposed to strings. And that only works when the document itself is processed by another MongoDB instance if we send it over. In MongoDB, every document also has a special field called the _ID, and that is used as its primary key until otherwise stated. This _ID is the default first attribute of every Mongo document, and we'll see how to use it in queries later on. The MongoDB query language is called MQL. It takes in a collection of documents and outputs another collection. There are three types of queries in MQL. Retrieval, which is similar to some of the SQL read queries that we learned about earlier. Aggregations, which is really a general form of retrieval queries, as we will see, and updates. Unlike SQL, however, all MQL queries are constructed as follows. We start with the name of the document collection, and we call various query operations until we are done with constructing the query. The result of calling these operations is a final output document collection. As we will see, each operation is applied to the single document collection, unlike in SQL, where we can include multiple tables in the from clause. In MQL, we use the dot notation to descend into objects and arrays. For instance, instock.quantity returns the quantity field within instock. If instock is a document or object, then this will return the quantity field within instock. If instock is an array, then this will return the nested field within the objects in the array. MQL also uses a number notation to reference array elements starting from 0. So for instance, .1 returns the second element in an array. So .1.quantity returns the second object's quantity field. Interestingly, MQL requires these dot expressions to be always expressed in quotes, which kind of beats me. Different operators in MQL are invoked using the $sign notation. For instance, greater than, less than or equal, etc. To construct predicates using these operators, we put them in the field part of a field, followed by a colon, and then a value expression. For instance, if we want to return all documents with quantities over 30, then we specify that as quantity colon, and then a pair of curly braces surrounding the predicate itself. We can also specify arguments to an operator as an array. For example, here we have the two numbers to be added specified using square brackets. Finally, as we will see later on in aggregation queries, we also use this dollar notation to specify the field names that we want to aggregate on.